Okay, everybody. So, this is Math 146, Statistics, and today we're going to be starting a discussion of Chapter 3. And Chapter 3 looks at averages and variation. So far in Chapter 1, we talked about collecting data. In Chapter 2, we talked about organizing data into largely tables and charts and that kind of thing, and graphical displays. In Chapter 3, we start looking at ways that we can analyze the data. And in 3.1, section 3.1, specifically what we're going to be looking at are measures of central tendency. So a couple of definitions, and then we'll look at largely the three most common measures of central tendency, which you've all probably heard of before, which would be the mean, the median, and the mode. So first thing to note is that we use the term average to indicate one number that gives a measure of center for a population or sample. Okay, we use the term average to indicate one number that gives a measure of center for a population or sample. One thing to be aware of is people tend to use the term average when they perform the operation where they add up all the numbers and divide by how many numbers there are. That is one type of average, but average is actually an umbrella term. A lot of things can be an average. And anytime we're taking an entire data set and boiling it down to one value that's giving a measure of center, or in other words, what is typical for that set of data. Anytime we do that, that's called an average. Okay. And we're going to look at three really common averages today. Well, and we're also going to look at the weighted average. So actually, we're going to look at four common averages. And that would be the mean, the median, the mode, and the weighted average. And we'll look at each of these in turn, and then we'll kind of talk about some of the pros and cons of each of them, because some of them are more appropriate for certain data sets than others. The mean is the thing that you most commonly hear people refer to as the average of a set of data. So for the mean, we add up all the data values and divide by the total number of pieces of data. Okay, so that's how we find the mean. Your book has two different formulas looking at the mean. One is for the mean of a sample, and the other is for the mean of a population. And how we compute these for the sample versus the population doesn't differ, but the notation that we use to look at them is different. Remember that values that we compute from a sample are called statistics, and that values we compute from population data are called parameters. Okay. The symbol for the sample mean is X bar, and this is on that purple symbol sheet that I gave to you if you've forgotten if you've forgotten to take a look at that recently, you can go back and take a look at that, and it'll have the X bar listed for the sample mean. And the way that we find X bar is we add up all the X's. This big capital Greek letter sigma, that stands for sum, or in other words, we want to add. And what we're adding are all the X's. Those are the actual data values. And then we divide that sum by lowercase n, and that's the sample size. So this formula says exactly the same thing as our verbal definition. We add up all the data, we divide by the number of pieces of data. It just says it in a much more compact form. That's what the formula looks like in symbolic notation. If we were to compute the mean for a population, we would do exactly the same thing. We'd add up all the data values and divide by how many there are. But the notation looks different. The population mean is symbolized by the Greek letter mu. That looks like a combination of an M and a U, so it's a mu. And it's equal to the sum of all the data values, so we still add up all the pieces of data, and we divide by the size of the population, which if we're talking about population size, it gets a capital N. Sample size gets a lowercase n, population size gets a capital N. Okay, so that's the mean. Let's take a look at an example where we compute the population mean, or rather the sample mean. Let's do that. So let's say for this set of data, compute the sample mean. And let's say we had a 3, 5, 8, 8, 10, 11, and 15. Okay, so there are our data points. First thing we would do to find the sample mean is X bar, we would add up all these pieces of data, 3 plus 5, plus 8 plus 8, plus 10 plus 11 plus 15, and we would divide by how many pieces of data there are. 1, 2, 3, 4, 5, 6, and 7. When we do that addition, 3, 5, 8, 8, 10, 11, and 15, we get 60 divided by 7. And we're looking at a value for our mean of about 8.57. You'll see me round to 2 decimal places a lot. That's perfectly fine. You could also keep 1. I wouldn't really keep more than 2, and I wouldn't really keep less than 1. And then also, because this is not an exact value, we approximated, you want to use the squiggly equal sign there to show that 60 over 7 is approximately 8.57. Okay, and there's our sample mean. The median for the data set is the actual middle value. So the median of a set of data is the value occurring in the middle once the data have been ordered. And it doesn't matter which way you order them. You can order them low to high or high to low, but once they're in order, whatever the value is that's in the middle, that's the median. Okay. So when we're looking at our set of data that we had up here, where we had our 3, 5, 8, 8, 10, 11, and 15, that set of data is written in order. And the value in the middle is right here, right? We had 1, 2, 3, 4, 5, 6, 7 pieces of data. So 3 pieces to the left of that, 3 pieces to the right of that. Here's the piece in the middle. That's the median. Now, it is possible to have a data set if you have an even number of pieces of data that doesn't actually have a middle value. So let's say we had 3, 5, 8, 8, 10, 11, 15, and 45, let's say. Well, now we have 8 pieces of data, and there is no value in the exact middle. So if you need to find the median of a set of data that has an even number of data points instead of an odd number of data points, what you do is you still put the data in order. Here's the lower half of the data, 3, 5, 8, 8. Here's the upper half of the data, 10, 11, 15, and 45. And what you do is you find the mean of the middle 2 values. So we would take those 2, add them together, and divide by 2, which would give us a value of 18 over 2, or 9, for the median. Okay, so when we had this, we grabbed the one in the exact middle. When we had an odd set of data, when we have an even number of pieces of data, we take the mean of the 2 middle pieces to get the median. And then lastly is the mode. And then we'll do some comparisons of those, and then we'll talk about the weighted average last. So the mode is the value in a data set that occurs most often. From our example above, you can see we've got 2 8s. Right? Either one of these data sets, 3, 5, 8, 8, 10, 11, 15, 3, 5, 8, 8, 10, 11, 15, 45. So the mode for that set of data would be an 8. Okay, because it is the value that occurs more often than any of the other pieces. You can have data sets that have no mode. So for example, if we had, instead of 3, 5, 8, 8, if we had 3, 5, 8, 10, 11, and 15, this has no mode because no single data value occurs any more often than any other one. Okay, that would be an example of a set with no mode. You can also have a set that has multiple modes. So if we had 3, 5, 8, 8, 10, 11, 15, and 15, here the modes are 8 and 15 because those 2 values occur more than any of the other ones. Okay. So we can have no mode, we can have multiple modes, or we can have a single mode, depending on how many values occur most often. Each of the measures of central tendency, each average, has some advantages and disadvantages in describing the data. Essentially, what we're trying to do is take a set of data and boil it down to one value that is representative of what's typical for that set of data. That's the idea with any measure of central tendency or any average. The problem is, depending on how you do that, you can misrepresent what's actually typical for the set of data. And I'll give you a few examples. The disadvantage of the mode, for example. Let's say that we had a set of data that looked like 3, 5, 8, 8, 8, 10, 11, 15. Actually, let's forget about 10, 11, 15. Let's say we had 3, 5, 8, 8, 8, 55, 69, 77, 78, 79, 101, something like that, okay? Let's say that was our data set. Well, if we're looking at the mode for this set of data, 3, 5, 8, 8, 8, 15, 69, 77, 78, 79, 101, the mode would be 8 because it's the value that occurs most often. But is it the case that the value of 8 is typical of what we're seeing for that set of data? Well, no, most of the values are 55 or above. We've got 50s, 60s, and predominantly in the 70s, and then one in the hundreds. This value of 8, even though it occurs most often, isn't actually representative of this set of data. So for this particular data set, the mode might not be what we would want to use as a measure of central tendency because it misrepresents what's typical for that set of data. Even though it's easy to count, it doesn't necessarily always do a good job of representing what's typical. Okay. To give you an example of one of the drawbacks of the mean versus the median, let's go back to our original sets of data. We had 3, 5, 8, 8, 10, 11, and 15, right? That was our original set of data. And when we found the mean, we found that the mean was 8.57. Is that representative of that set of data? Sure, that's actually a pretty reasonable value in the sense that, does it appear that 8.57 is typical? Yeah, 8's right about in the middle. We've got a couple of values lower than 8 and a few higher, so our mean is just a little bit above 8. That seems pretty representative. The problem is what happens when I add in what are called outliers. Outliers in a data set are values that are very far removed from the bulk of the data. Okay, so let's say that I had this extra value, and let's see, I think the one that I picked was 45. So 3, 5, 8, 8, 10, 11, 15, 45. By adding in this one piece of data, let's see what effect that has on the mean. So if I take those and add them all together, 3, 5, 8, 8, 10, 11, 15, and 45, I get 105. And if I divide 105 by 7, I get 15. Okay, so when we have this set of data with the 45 included, our mean jumps up to 15. But would you say that 15 is typical of that set of data? Well, probably not really. We only have 2 values at 15 or above. The bulk of the data is actually below that mean of 15. So just by having this outlier in there, it skews the mean. It pulls the mean toward the outlier. By contrast, the median of the set of data without the outlier was 8. Even when we add the outlier in, because the median is based on position in the data and it's not based on the actual data value, all that happens when we add in this piece 45 is then we have to average find the mean of the 2 middle values to come up with our median. And our median at that point is 9. Okay, so notice that by adding on this outlier value of 45, our mean moved a lot, our median barely moved. Okay, this is a really central concept when we're talking about measures of central tendency, and the notion there is that the mean is very sensitive to the effect of outliers. Okay, it's very sensitive to the effect of outliers. Another way to look at this, the wording that your book uses, is that it is not resistant to extreme values. Okay, so the mean is not resistant to extreme values. However, the median is. So generally, if we know that our data set has an outlier, we would use the median rather than the mean. The mode actually doesn't get used all that often. Mean and median tend to be the ones that are used most often, and between those two, what makes the biggest difference is, are there outliers present? If there are outliers present, we would most likely report the median. If there are no outliers present, we would most likely report the mean. Okay. And those are your 3 basic averages: mean, median, and mode. There's also a weighted average. And the idea with a weighted average is that sometimes certain types of data are more important to us than other types of data, and we need a way to take that into account. And I'll give you an example of what I mean by that in a second. So with our weighted average, at times, we may need to assign more importance to some of the data values. And that's really what the weighted average allows us to do. It's another way to take the average or to compute a measure of central tendency, but to make it so that some data values are more important than others. And the formula for the weighted average is to take the sum, whoops, let's try that again. The sum, there we go, that is that big Greek sigma that means to add, the product of the data values times their weights divided by the sum of the weights. Okay, so we're going to add up the product. Product, of course, means to multiply. Data values times weights divided by sum of the weights. So here's an example that's similar to one that's in your book. Let's say that we had some nursing staff, nurses, and let's say that we wanted to look at giving them merit pay. So the nurses who perform better in their job, we want to pay them more. The nurses who aren't performing as well, we want to pay them less. And we might have a few categories where we evaluate our nurses. And I think the categories in the book are promptness, appearance, record keeping, and bedside manner. Now, it's not the case that all of these four things are of equal importance to us, right? Generally speaking, you might not consider a nurse's appearance to be as important as, say, his or her record-keeping abilities. That seems to be more important than appearance. So we might weight each of these categories to tell us which ones are more important. And the more important ones will have a heavier weight. They'll have a larger weight assigned to them. So let's say if we felt that record keeping was the most important thing. Okay, that was most important to us. So let's weight that a 4. Let's say promptness is next most important, so we'll weight that a 3. Let's say bedside manner, how you are with patients, are you friendly and all that kind of stuff. We'll weight that maybe a 2. And then maybe the least important thing to us is appearance. Okay, so there are the weights. Now let's say for a particular nurse, we have the following scores. Let's say this nurse scores on a scale of 1 to 10. Okay, so let's say they score a 7 in promptness. Let's say they score maybe a 5 in appearance, an 8 in record keeping, and a 9 in bedside manner. They're really great with patients. Their record keeping's pretty good. Their promptness is okay. Their appearance is meh. Okay. Now, if we want to compare nurses to one another, it's really inconvenient to just look at these 4 categories. It would be nice if for each nurse we could come up with one single value and then we could compare them to one another to figure out who's doing the best at their job and who is entitled to these pay increases. But again, we don't want to take into account just these raw scores. We also need to take into account the weights because some of these scores are more important to us than others. And that's really what the weighted average does. So the way that the weighted average works, we need to find the sum of the products of the data values and the weights. So the products just mean to multiply. So I will take each data value, each score, multiply by its weight. So I get 21 in promptness, I get 5 in appearance, 32 in record keeping, and 18 in bedside manner. So there's what we've got for the products of the data values and the weights. Then the formula says to add up all of those products. So I will add them, 21 and 5 and 32 and 18 gives me a total of 76. And then it says to divide that value by the sum of the weights. So if I take all the weights and add it up, 3 and 1 is 4, another 4 makes 8, and 2 more is 10. So this nurse, their overall score is a score of 7.6. And now I can quickly and easily compare them to other nurses because we've boiled down their overall performance to one single score. Okay. That's the idea with section 3.1. You'll also see some discussion in the book about a trimmed mean. We're not really going to discuss trimmed mean. You're welcome to take a look at how it's computed, but we're not really going to go over that. Also, there are some parts in the book, some critical thinking parts that you'll want to take a look at, talking about which averages are appropriate for which level of measurement, nominal, ordinal, interval, and ratio. And also there's some great graphics in your book looking at how skew affects the values, the relative values of the mean, median, and mode. So take a look at that in your book too. There's some graphs showing you that. Also, if you watch the next video, that will show you how to do a lot of this computation on the calculator. Your calculator will find median, it will find mean, and it will find a weighted average for you. The only thing it won't find for you is the mode. The mode you'll have to come up with manually. So that'll do it for section 3.1. If you have any questions, feel free to bring them up in class. Thanks for watching. Okay, so this portion of the video is going to show you how to do, how to find the mean and the median, and also I'll show you how to find the weighted average using your calculator rather than computing them by hand. By hand, if you have a small data set, finding your mean, finding your median, finding a weighted average is pretty straightforward. But if you have a large set of data, say, more than 10 pieces of data, it can be kind of cumbersome, especially depending on what your values are. So first, let's put in our data, and we'll do this just like we've been going over in class. Anytime we want to input data into the calculator, we will go to the stat key here. So I pressed stat, and then you can see there's my list of options in my submenu for stat. And what I want to do is edit. We want to do stat edit. So I'll just press enter. And then here, of course, if you had some data in one of your lists, you would want to clear that out. We don't have any data in here yet. So I want to put it in, and I'm just going to make up some data. Let's say we had like 5, 6, 13, 24, 32, and 50. Let's say those were our pieces of data, okay? So 5, 6, 13, 13, 24, 32, and 50. Okay, there's our pieces. And you would just keep entering until you had all your data entered in. Then, if we want to compute values for that list, we'll press stat. And then this is something we haven't done yet. Everything that we've done so far has been editing. We've been inputting data, we've been sorting it, we've been clearing things. We haven't done anything with calculating yet, but that's exactly what we want to do when we want to find, mean, median, and so forth. We want to calculate. So we'll press the right arrow key to scroll over to the calculate submenu. And what we want to calculate are one variable stats, single variable statistics. We only had one variable that we were recording, one set of data, so we want the one variable stats. So you can either hit the number 1 or you can press enter. And that'll select your one variable stats. Now your calculator at this point has the blinking cursor, and it is waiting for some kind of additional information from you. Basically what it wants to know is, do you want one variable stats of list 1, or do you want one variable stats of some other list? If your data are stored in list 1, like mine were, I can just press enter right now, and by default, the calculator will find one variable stats for list 1. If your data are in any list other than list 1, you'll have to tell the calculator the list for the data. So if you wanted to find one variable stats for list 3, you'd have to press second 3 right now. Even if your one variable stats, even if your stats, are in list 1, you can press second 1 and tell your calculator you want to find one variable stats for list 1. Okay, and that's perfectly fine. And then you press enter. And your calculator is going to give you a ton of stuff. For the most part, in 3.1, we won't be using all of this. We'll be using a few pieces of it, but not other pieces. So let me tell you what all of this is for now. X bar, that's your sample mean, 20.42, or roughly 20.43 if we rounded to 2 decimal places. That's the mean of the data. This is your sum of all the data values. So if you needed to know what would you get if you totaled all the data, it's 143. Here's the sum of the squares of the data values. So if we took all the data values, squared them, and added them all together, we'd get 4499. These two, Sx and small sigma x, those are both standard deviations. We won't talk about those until the next section, 3.2. Here, n equals 7, that tells us we had 7 pieces of data. And then you'll notice there's this arrow key. You can scroll down using your down arrow on the calculator to keep looking at more stuff. It tells you your minimum value for your data is 5. Q1 and Q3 we won't do anything with until later in chapter 3, so you can ignore those for now. Your median for your set of data was 13, and your maximum for your set of data was 50. Okay, so if what you need is your median and your mean, for example, median is 13, and mean way back up here at the top, 20.43. Okay, so that's how you find mean, median. Mode your calculator does not find, you have to find that by hand. I'm going to go ahead and clear this screen. Let's say that instead of finding mean, median, and mode for just a single set of data, let's say I wanted the weighted average for a set of data, like when we were talking about our nurse that had the different data values. So I'm going to go in here back to my stat and edit. I want to get rid of all of my data that are in list 1 because I want a new list now. So I want to go up to list 1, press clear, and enter, and that will clear out my list. So now list 1 is just blank. And so let's say I had, again, we're kind of imagining a nurse, and we had those 4 categories: record keeping, appearance, promptness, and bedside manner. And so let's say I had my various scores of 8, 3, 7, and 6. Okay, those were this particular nurse's individual scores. So your scores or your data values go in list 1, and then the associated weights would go in list 2. So if this number 8 represented record keeping was the most important thing, if I recall correctly, so we would have that weighted at a 4. This next thing, let's say that was promptness. So promptness, I think, was rated at a 3. Then let's say this is bedside manner, that was rated at a 2. And appearance, the last category, that was rated as a 1. But the really important thing here is that you have each score directly across from its weight. Okay, so regardless of what categories these are, we're saying the score of 8 has a weight for that category of 4. You could have all of these same pairs of data in a completely different order as long as they were paired up properly. Okay, each data value with its associated weight. So you've got data values in list 1, weights in list 2. To compute the weighted average, we go back to stat, and we go over again to calc, so we'll press the right arrow key. And this may seem confusing, but we still want one variable stats. We don't actually want 2 variable stats because all we collected was information about that nurse's performance. The weights are not considered a second variable. Okay, so we have performance values. We don't have performance values in something else. We have performance values in weights. So we're still going to compute one variable statistics. And our data are in list 1, so we'll tell the calculator that. And if you pressed enter right now, all your calculator would do would be to find the mean and the median and all of that for that first set of data, which doesn't take into account the weights at all. So we need a way to tell the calculator, hey, we want the one variable stats for list 1, but we want you to take into account those weights. And to make that happen, you press comma, and then tell the calculator what list the weights are stored in. So if you have your weights stored in list 2, you would press second 2. And this will find the weighted average for your data that are stored in L1 if your weights are stored in L2. Okay. And then press enter. And this guy right here, this is pretty much the only thing you'll be using. You won't really use the rest of this stuff. But this tells you, hey, your mean, your weighted average in this case is 6.1 for that particular nurse. Okay. And that's pretty much it for the calculator stuff that you'll need for this section. We will be doing more stuff with the calculator in section 3.2, largely focusing on these two values right here, the SX and the sigma X. So we'll be talking about those in class when we get to section 3.2. If you have any questions, please feel free to bring them up in class, and thanks for watching the calculator piece.